All right, today we are going to talk about making inequalities true. So, the goal is that by the end of this lesson, you will be able to determine if solutions make inequalities true or false. We already know that solving means that we are finding the unknown values. We also know that inequalities are mathematical sentences comparing expressions. This is different from equations. Equations have equal expressions on both sides, whereas inequalities, they don't have to be equal. And instead, we are comparing these two expressions. Some examples here are C is greater than or equal to 4, or X plus 2 is less than 5. We know that the solution is the value that makes the statement true. For example, in X plus 4 equals 7, X equals 3 is the solution. Our new word or phrase for today is solution set. And a solution set is when we have a set of all solutions that make the inequality true. We know that there are many numbers that can make an inequality true. So all those numbers together would be our solution set. For example, X plus 4 is greater than 7. Well, the solution set would be X needs to be greater than or equal to 4. So any number greater than 4 would be part of my solution set to make this inequality true. So we're going to practice substituting in, and this is just like what we do when we substitute in for equations. So I've got the inequality X plus 3 is less than or equal to 7. My value of X is down the side here. And I need to determine if this value, each value, is going to make my inequality true or false. So I start by rewriting my inequality. And then I plug in my value for X. So here I've got 3 plus 3 is less than or equal to 7. Now, I go ahead and simplify that out. And I'm left with 6 is less than or equal to 7. Well, is 6 less than or equal to 7? It sure is. That means that this is true. We move on to our second one, saying X plus 3 is less than or equal to 7. I substitute in my 4. Again, I simplify. And now my statement reads 7 is less than or equal to 7. Wow, 7 is not less than 7, but it is equal to 7. So that makes this statement true as well. One more here. We've got X plus 3 is less than or equal to 7. I plug in my 5 plus 3 is less than or equal to 7. Again, simplifying out. This time my statement reads 7 is less than or equal to, 8 is less than or equal to 7. That is not true. That would be a false statement because 8 is not less than 7. If you go ahead and move on to that second page here, you'll notice that we have two different types of problems here that we'll see. The first kind of problem that we have is substituting in one value and determining whether the statement is true or false. The second type of problem that we have is given a list of solutions, and we have to determine which, if any, will make our inequality true. So we're going to start up with our first section, and this is where it says to tell whether the given rule is a solution of the inequality. So all we're going to say is true or false. So I take this, I plug in 9 for X. 9 minus 1 is less than 7. Again, I need to simplify. 9 minus 1 is 8 is less than 7. Well, 8 is not less than 7. Therefore, this statement is false. Moving on to number 2 here, we've got y plus 5 is less than or equal to 13. Again, I take my 8, substitute it in for y. I've got 8 plus 5 is less than or equal to 13. Simplify it, giving me 13 is less than or equal to 13. Well, 13 is not less than, but it is equal to, so therefore my statement is true. So quickly, I want to point out that I can do the work and I substitute in, but my response is that true and false. So this right here is my work, and then this is my response. Both are required when we are solving problems like that. I want you to tell me whether it's true or false, and then I also want you to use this. This is justifying your answer. That's the evidence for your response. All right, two more like this. We've got 3z is greater than 6, so I go ahead and plug in 3, giving me 3 times 3 is greater than 6. 9 is greater than 6. This would be true. 9 is larger than 6. And then lastly, I've got my b. And remember that fraction bar right there, that means to divide. So we rewrite that as 10 divided by 2 is greater than or equal to 6. 10 divided by 2 is 5. And 5 is not greater than or equal to 6. So that would be false. Moving on to the second set of questions, this is where we determine which of the following numbers, if any, make the equation or inequality true. So what we need to do is plug in each of these numbers for x. I can do that a couple of different ways. The first thing I can do is I can just write it out again and plug every single number in. So if I take that, I write 0 plus 5 is less than 13. 5 is less than 13. That is true. Yep. I can do that and I can go down my entire list. Or I can kind of see where I think and kind of, in this example, all my numbers are in order. So watch. If I go ahead and then plug in my next one and say x plus 5 is less than 13, and then, okay, 5 plus 5 is less than 13. 10 is less than 13. That's true. Great. Moving on to the next one. Then I've got x plus 5 is less than 13. 8 plus 5 is less than 13. 13 is less than 13. That is false. Now, if I were to plug in 10, which is bigger than 8, I know that my answer right here, simplified, would have me greater than that 13, making that false as well. Same with that 14. So I can technically stop here. The biggest trick needs to be that you need to make sure your number's in order. If your numbers are all jumbled up, you need to make sure that you are paying attention and circling every single option that is true. Let's do one more together. We've got 3x is greater than or equal to 20. So again, I can go ahead and plug that in. Well, I start here and say 3 times 0 is 0. That is not greater than 20. So that's false. So I keep moving on. 3 times 15, times 5 equals 15. That is also false. 3x is greater than or equal to 20. We've got 3 times 8. That gets me 24, which is in fact greater than or equal to 20, which means that if I plug any of the rest of these in, they will all be greater than 20. Now, if I want to continue proving that, that is totally fine. Again, when you're doing this, please make sure that your numbers are in order, or if not, that you're paying very close attention and making sure that you have selected all the true statements. Awesome. Thanks.